computer. Okay. All right. So chapter 4 stuff. I think we did the whole worksheet between a couple of videos. I don't think we did it last time, but between Monday and Wednesday of last week.
Yes, that's correct.
It should all be there.
I was in the day classes, and I know
and
on the day one we did a lot, but we didn't get to the part where I was at the end of the one. So I will look at those. Thank you.
Yes, yes. And then, yes. What about, I think we did like all of 5.1 and 5.2, all of the 5.1 worksheet stuff too in class. So I don't.
We didn't do the last page. We didn't do 5.1. Oh, you're talking
Go ahead. This one?
5.1. That one, I'm having a hard time with that.
We
Okay.
ended at 4.
Oh,
We didn't finish the rest of it.
We
Yeah.
didn't finish 4, like we talked about it, but didn't
Yeah,
fully
that's
finish
true.
that, right?
That's right. Okay. Is there anything y'all need on this stuff?
Yeah, I'm confused about where we're at exactly.
So we're on page 548. And last time we had talked through, I think, up to number 3, and we'd actually done it. Right? It was no, yes, no. And this one had a negative value, and this one, the sum was not equal to 1. And then I had just said, oh, here we're just talking about words. And we're looking between 0 and 1 and 0.5, and this is impossible
Mhm.
versus certain. Any of these, any ones of these you couldn't figure out?
I couldn't get any of those. Of 4. I was so lost.
Those 3 things, the impossible, certain, and unusual, are in our notes because I've been rewriting stuff.
Make that better.
What page is that on? It's one of those gray boxes that we see.
Let's see, I bet we could find it here, chapter 5.
It's on page 137.
Here we go. I was about there. Yes. Okay. Wait for it. Here we go. Yeah. Possible event is 0. Certain event is 1. Unusual, anything less than 0.05. So what?
What page is that?
137
In the notes, Jen.
of the notes. And I think you would have covered this with Cindy on Monday of last week. Does that seem right?
On Tuesday.
That's the class I missed.
So let me fill in like 1 or 2 of these. Like, let me do this one real quick. Someone made a mistake. We know the number has to be between 0 and 1. So if you look at F and H, those are both numbers outside of that. This is the page 548. Oh, there we go. So both of those are the 2 where we were like, nope, we can't do that. Or those numbers aren't possible. They're meaningless. So that's definitely a mistake.
Can those also be 6? This event cannot happen? Because that's what I have, 6 and 7.
So it can't be 6 because this event can't happen is exactly 0. Can't be anything else, if that makes sense. I
Okay.
get what you're thinking, like, oh, we can't have that probability, but the language here, the word event is a specific word in probability, right? That is some collection of outcomes from our probability experiment.
Okay.
And so this has a number assigned to it. So which is 0, or this cannot happen. Whereas these numbers can't be assigned to any event because they aren't sensible.
Okay. Well, see, for B, I put 5 and 6. So it isn't 5 or it's just.
Well,
6?
you know, 5, so, okay, this is being super picky,
I know.
but I think it makes sense. Hear me out. 5 says it would be unusual for this event to happen. Well, I totally agree with you, by the way.
Okay.
And I don't know that uncertain or impossible, or it's not going to happen, would be considered unusual.
Okay.
Because unusual suggests that it still could happen.
Isn't that the key word?
That's the key word. So, right, you're queuing in on the correct fact that it's any number less than this, but then we're like, and you're like, yes, 0 is less than 0.05. But I think cannot happen goes beyond unusual.
Okay.
We even have a definition, I think, wasn't it in the notes that there was something that was highly unusual, which was like less than 0.01 even? Maybe not.
All right.
It's being
So-
picky, but go ahead.
Would D be number 1?
Yeah, 100%. Good.
Mhm.
The event is certain to happen. That's, yeah, that nailed it. Good. See if I can spell it. I can't. It's right there. That's how you spell it.
So is,
I mean, let's just go down the line. So like A, I have 2. This event is likely to happen as not.
Good.
Yeah, agree.
Okay, C, 1.
90% chance means that there's a 10% chance it's not going to happen.
So it'd be number 4.
I had 4.
I have 4
Good.
as well.
Yeah, that's a better answer.
Yeah.
Very likely it's going to happen, but not guaranteed. Good.
Okay, and we already know what D is, and then E. Okay.
E's number 3.
Good.
Yeah.
You see that it's not unusual, right? It can't be number 5. It's not equally likely.
It's over 0.5.
That's right. So it could happen, but it's not particularly likely. So remember the little thing I wrote here is anything less than 0.5 is less likely to happen than happen, and anything above 0.5 is more likely to happen than not happen. So it's kind of playing on that thought process.
So
You don't
then-
want to bet on anything below 0.5 because you're not likely to win.
So then G would be 5.
G is the only option, is the best option for 5. Yeah.
Okay.
Most important question is there going to be a question like that on the midterm?
So I have remembered grading. I don't remember it on a midterm because we used to do 3 exams in a final. I remember grading a question similar to this where it was like a list of these and then a statement kind of like this, and you had to select one. Another common question is which of these could be a probability or which of these numbers cannot be a probability? And there's like decimals, fractions, and percents. And it's really testing, do you understand probability can only be between 0 and 1? That one is more likely to be on the midterm than one like this one.
Yeah,
So
there's
if
too
we
many
wanna
options.
Remember, if we want to remember anything, we need to put this chart in our notes
Yes.
to refresh our memory on what to put down.
What can a probability be as a number? I think that is pretty important, especially for interpretation purposes. Keeping in mind that there are things, it's a way to, like, when you do a calculation and you get a number, like what we're going to do today, is that number correct? Well, does it fit between 0 and 1? Then it might be. This one we talked about, right? It's got to be, you got to remember that this is a quartile, a box plot. So each of these quartiles are 25%.
I think my answer's wrong. I got the same answer for both.
Well,
I know
might be
that's
right. What was your answer?
0.5 or 50%.
Well, let's see, where is 18.5? Does that feel like this is 18.5-ish? As the median, 18.5 million? And then we're thinking above that,
Yeah,
what
above
percent
that. Mhm.
would be above that? So what percent of the data is here?
Well, was it
50%.
50%?
Oh, that seems reasonable.
Okay.
Now, these are disjoint questions because there's no overlap between what you're being asked about. So they could have the same answer and be fine. Less than 37, let's see, where do we see 37? Here is that feels like 37-ish, right? Less than, it's gonna go this way. What do y'all think about that one?
75%.
75%.
Good. So they were not the same answer, but that doesn't.
Okay.
This question is almost the exact same question as what we did back in chapter 3, where you had the empirical rule, right?
Yeah, I like those better.
Well,
Well,
I
there's
was
more to keep
confused.
track of. This one, there's only 4 things.
I was confused, like, I don't know why, but how to get the answer
That the first thing is you had to
until you
recognize.
said,
there's
it's
a
like,
box
oh,
for that. Yeah.
Yes,
Thank you. Have a good night.
thank you.
Okay. How'd you all do with this one? Use the multiplication rule. How many ways can 4 questions be filled out randomly by the student?
Oh, I got number A, and that's as far as I got.
What'd you get for A?
I got 16 outcomes.
Does everyone agree?
That's what I got too.
First question, 2 ways. Second question, 2 ways. Third question, blah, blah, blah.
Yeah.
Multiplication rule says multiply them together. Good. 2 to the 4th, which is 16. Love it.
Yeah.
Okay. The tree. Hooray. Should I blow your minds and draw it this way?
Go back up, please.
Yeah.
Yeah.
So,
Oh, that way.
No, you don't like that? I shouldn't.
No, I like that.
Oh, that's so much neater.
You
Yes,
like that one better?
mine looks like a snowman's arms or something. Just
but why did we use 2 on A?
Great question. It's true or false. So question 1, when you're guessing, you can either guess true or false. That's it.
Gosh,
Question 2, same thing, right? True or false?
okay.
Same thing for question
See,
3.
I
All right.
was 4 was where my mind, 4.
I got,
Four.
well, you weren't wrong to think 4 because there was 4 times that you did that.
That is such a cleaner way to draw that.
yes. Why didn't we?
You should have led with that, Eric.
Yes.
I know, but we do it differently in the book.
That is so much cleaner.
so
Thank God for whiteout.
Yeah, just right over top of it. That's cool. Make me hunt.
Oh man.
So this is kind of, if you do it the vertical way, this is how it works out. This branch is from question 1, and then after question 1, we build question 2's branch, and then question 3, and so on. Now, this is not the answer, right? The answer is the sample space.
Right.
Now is where it becomes harder to read, in my opinion, because I'm not as comfortable reading down as I am reading left to right, which is probably why we tend to draw it left to right. Because here's that one. And then the next one is true, 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 false. And I think I'll leave this for you all to fill out. That's that one. And then we got to get this one and so on and so forth.
all right, so the top is Q1. The second row would be, okay. Q2. I don't understand what we're,
Those are the questions, the 4 questions from answer question above, Jen.
Yeah, there were 4 questions we had to randomly guess. Don't do that on the exam, by the way. I mean, you can.
I have a
This is
question.
where we're like, haha, you didn't study, so you're just gonna randomly guess.
So where's the 2 coming from? That's what's confusing me right now.
Great question. It's the true false. It's the options for each
Oh, the 2, gotcha, okay.
question. So each question you can pick from 2 things. If it had been, say, an ABC question, then it would have been a 3.
Gotcha.
Or ABCD, then it'd be 4.
I was confused by the same thing, Patty.
I'm so glad I'm not alone.
That's the fun thing about math, is there's always someone that has the same confusion. Guarantee it.
At least I'm at the age now I don't have a problem admitting that I'm wrong or acting happy to ask questions.
Yes, I'm so with you. There's so many people that are fearful. I was that way too.
Me
In
too.
my grad classes, I didn't want to ask anything.
Mm-mm.
I mean,
Although the professor knew me, so he kept calling me out. What do you think, Eric? Leave me alone. Go ahead. I cut someone off.
mhm.
Okay, so let me just say one thing down here, and then we should get on to the 5-2 stuff.
Mhm.
And that is that the divisor for each of these initially, if before we reduce the fraction, is 16. And I will say to those of you who haven't seen the notes on any of this yet, this should be crazy overwhelming.
Mhm.
And you should be like, I have no clue what's going on.
that's me right now.
Yeah, so take a deep breath and say, I need to watch the notes.
Yeah.
It's like what can I think of that's a great explanation? It's
so
like
much
trying
confusing.
to run a marathon having never trained. We're like, hey, here's the practice problem. We're going to practice what you've been doing for the last 50 years. And then instead you haven't had a chance to do any of that. And so you just go run and your legs break and you fall apart and you can't do it. So don't beat yourself up. That's my message. Use it as motivation to go watch the videos.
Yeah, so Jen, this would have been last Tuesday's video.
Which is 9/27. I don't know. My organization structure for the YouTube videos, right, is I just put the date on it, which is bad. I need to. I'm operating. I'm sure you've noticed. I'm operating at a bare minimum, so I'm doing the best I can. Which isn't good enough, because did anyone meet the 1:59 a.m. deadline yet? I got the morning classes switched.
I switched them for you, Eric.
Oh, thank you, Cindy.
Mhm.
Cindy's doing my job for me. Yeah.
Can we just really quick go back up to B, because I'm having a hard time following it written this way. So
Yeah, that's why we don't write it this way.
I am having, I mean, it's easier to write, but to read it and to follow.
Becky, I switched. I switched. I turned it around.
Yeah, let me go back and do that too. I think it makes, like, the point is to be able to write this, not to write it out easily. So let me rewrite it. I think I can do an okay job
Oh,
left to right.
well, okay.
I,
So here we go. True, false. True, false. True. So if we were answering 2 questions, this would be the tree. If we were asked to answer 3, which is the most likely option, if I ask you to draw something on the midterm, which I probably won't, but if I were, this is most likely the extent of the tree.
Well, thank goodness for small favors.
And then here we are at 4. True, false. True, false. And this I do agree, Becky. This is much easier to read. Although now I'm starting to ruin it. Also, T's and F's are really easy to not write very nicely. Okay. So T.
All right.
Check. That's the first row. Alexa, I do believe you are correct. And then TTTTF. So how I'm reading that, in case you're not following that, oh, pretty pink, here we go, is I'm saying this is a set of 1 branches. This is the next one. So that takes care of the very last true false question. I then still have these 2 branches. So maybe it's better to start from the right and go left. So TFTT, I'll write it as right from left, TFT. And then FFTT, which I'm going to write frontwards. Doesn't matter the order you write these things, just as long as you get them all. And then TTTFT. I think I said too many T's. And then TFTF.
Oh, gosh.
Okay, TFFT. So now I think I'm doing the best way to read it for you all. I'm starting on the far right. I'm drawing back to the start so I know where to start, and then I'm reading left to right. TFFF. That takes care of the top half. Let's check. 1, 2, 3, 4, 5, 6, 7, 8. That's all the ways of guessing true on the very first question and all the combinations of the next 3 questions.
Okay.
We could draw a line in between that and say, all right, here comes guessing false first. So FTTTT. And then FTT or FTTF. That's a cool symmetric one, right? It's the same frontwards and backwards.
Mhm.
I got way too many T's there. Let's get rid of that one. So F T T F, and then F T F T. Oh, that's another one that's the same front and back. No, it's not. And then F T F F. FFTT. This one has 3 F's, FFTF. Okay, FFFT. And finally, the last one, we're just FFFFF.
Okay, after the FTFT, what is that one? Is that
This
an
one that I
FF
just erased.
or no, the one right below the one you just erased?
Oh, good, because I don't remember which one I just erased. Oh, and that's FFTT. But here's the cool thing.
FFTT, okay.
I
So
can,
that both of them are the same, that one and the one below it, there's two FFTTs.
No, this one's an FFTF.
You're missing one, aren't you?
I just erased it because I was gonna try to draw it better, so. Now I'm gonna go back to this one. So I
F-
know it's the
okay,
1,
so-
2, 3, 1,
F-
2, 3. It's this one, which is a FTFF. This is the one I erased.
T.
Whew. Okay, I guess I could try to clean up this one too. All these Fs are just. Oh no, I got rid of that T. Doesn't help writing with this pen.
Okay, I hope I got that right.
Okay, so that's our list. And then let's check, let's check Alexa's answer for D. Assuming the outcomes to be equally likely, find the probability that all the answers are false. Oh wait, that was for C. So how many outcomes in here have every single option false?
Just one.
Patty's right. She said 1.
Oh, perfect. I missed it. There we go. It's just this last one, right? That's the only one that has all 4 false. Okay. So let's get to D. Assuming the outcomes to be equal, like you find the probability that exactly one of the 4 answers is false. So what we're looking for is all the places where there's just one F in the 4 outcomes. So this one only has one F. This one only has one F. This one only has one F. Womp, womp, womp. Oh, this one only has one F. Womp, 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 womp. Yeah, 4 out of 16. There were only 4 places where we guessed one option false. If you don't like reducing, it does say you have to reduce,
Wait, what?
then go to Desmos, type 4 divided by 16, and click this little button on the side, and you get your 1/4. This little fraction button.
So the 1/4 is the answer for C.
For D. C is 1/16.
Okay, C is.
Because there's only one option where all 4 questions were answered
E
false.
is 4/16. Okay. So then.
Well, this last one, we might as well do it, and then we definitely got to move on, so we have time to look at the new stuff. We're saying that exactly 2 answers are true and 2 answers are false. So we're looking for 2 Fs and 2 Ts, doesn't matter the order. So if I start from the bottom, I got this one,
So,
this one,
what?
this one, this one, this one, and this one. Man, what is up with my computer? So that's exactly 2 T's and 2 F's. So 1, 2, 3, 4, 5, and 6. 6 out of 16. I knew the 16 was the beginning divisor because that's what we determined in A. And
I
that was-
got 7.
Oh, did I miss one?
Yes, because we want it with 2 F's and 2 T's, right?
Mm-hmm.
So
Yeah.
Which one did I miss?
You're good, Eric.
oh, no. You're right. I accidentally marked one that was not
Gotcha.
supposed to be marked.
No worries. Been there too many times. So
So-
if you don't like simplifying it yourself, it's 3/8. If you want to know how you did it, if you're wondering how this became 3/8, 6 and 16 are both divisible by 2. 6 divided by 2 is 3, 16 divided by 2 is 8. Okay. What fun we have. So, for the sake of time, I never closed what I wrote down this morning for the reference sheet material, like the overview. We already talked about this. Probability is this, it can be represented by this number line, where we go from impossible to certain, equally likely being the middle, and it has three representations: decimals, percents, or fractions, but they have to be a number in here. And the most difficult ones, or the ones that can trick you up the most, I think, are the fraction or percent ones. Because decimals, as long as there's a 0 in front of the decimal, you're good. Percent, you know, if it's 125%, do you recognize that's more than 100%? I don't know. And with fractions, do you get that 5/3 is not a valid probability? Like, that's the thing that could trick you up. What you could do is just do the division of the fractions if you think that's going to mess you up, and see if Desmos gives you a number between 0 and 1. So that's kind of the broad stroke of what's happening here numerically. We then get to this definition, this probability experiment, which is that that thing that's a repeatable thing, right? Like you can repeat whatever's happening, and there's clearly defined outcomes. So any game of chance is that. I mentioned this morning talking about students attending Jackson College and how we predict the number of sections of, say, 133 we need. We look at prior data and say, okay, what happened in fall, what happens in winter, and we use that kind of as our gauge, kind of like a probability experiment. Then there's three types of calculations we can do. Classical comes from theory. It's where we know all of the outcomes that could ever happen from the beginning. So any card game, any rolling of dice, we know what the things are. We just don't know when we perform the experiment what's going to happen, but we know the chances that things are going to happen. Empirical probabilities, it's a data set. So all of the tables you were filling out in chapter 3, and you were calculating relative frequencies, without knowing it, you were setting up empirical probabilities. And then the less useful one, although it's still useful, is the educated guess one. That's what we call subjective. Experts in the field can make predictions. And then the way you put together a probability, this is the notation. You do P parentheses and then naming of some event. Sometimes we name the event, let E be this event, and then we have P of E in there. Sometimes we just put inside the parentheses the actual thing. Like, what's the probability you roll a 1 on a 6-sided die? That's one way you can roll it out of 6 ways that things could happen. So the number of outcomes in the event divided by the number of outcomes in the sample space. That's the key to calculating probability. And these things can get super complicated, like what this number is and what this number is, and can get crazy. We don't get too much of the craziness in our class, but I saw some in grad school. There's whole grad level classes just on probability. So that leads to understanding the word sample space, which is all of the outcomes, all the possible outcomes for a particular experiment. Super important, you know how to at least get the number, because that's what you need in the calculation. So ways to help ourselves is what we just did. Build yourself a tree diagram, and then you can list the individual outcomes. That's only useful in really small probability setups. Even going into 5 questions, you get 32 branches at the end, and that's annoying. So we have the multiplication rule that you should definitely know how to use. Multiply those options together. And then finally in 5.1, we talked about the valid probability model. You need to have the sum, or you need to have each individual probability be a number between 0 and 1. And then you've got to have the sum of all those probabilities add up to 1. super important point. If that doesn't happen, then something's wrong. And none of the theory we talk about applies. So 5.2, we really only got three concepts. Talk to me. Oh, I'm going too fast. You're right.
Yes.
Slow down. So what you're seeing is what, for those of you that haven't seen the notes yet, is you're going to get all the holes filled in from watching the 5.1 video in the note for the notes. This is all fleshed out with worked out example problems and the rest.
I'm good.
Okay, so oops. So then what is wrong with this? I think I need to restart my computer or something. There we go. There we go. Okay. So 5.2, we don't add a ton of stuff. We add in a definition. What's a disjoint event? Really, I should say, what are disjoint events? Because you have to have two events in order to talk about disjointness. And what that means is there's no common outcomes within each event. So there's no overlap between the two events. And then the other option between the two events is that they're not disjoint, meaning they share common outcomes. So either they don't share outcomes or they do share outcomes. Those are your only two options once we have two events. So then we ask you to calculate an OR inequality. What's the probability E happens or F happens? Well, if the events are disjoint, if this is true, then the overlap is equal to 0. So we don't need that part. And the only thing we're calculating is the sum of the probabilities of the two events because they're disjoint. If they're not disjoint, we have to subtract the probability of overlap, the number of outcomes that are in both. And we're going to see some example problems of this in a second to complement what you already saw in the notes, which leads us to the complement. This is a very specific thing. There are three notations. E raised to the C power, if you will. It's just notation. It means E complement. You could also see E prime, or you could see E bar. The key word with complement is not. So we define event E. And then E complement is everything that's not in E. So by definition, E and E complement are disjoint events. There cannot be overlap between the two. And if we want to know what the sample space is, combine E complement and E, and you have all the outcomes in the sample space. Sometimes that's useful, not for us, but in higher level math, it's super useful. It also leads us to a nice little shortcut formula. This is not something you have to use, but it sometimes makes calculations faster and simpler. And that is, if we already know the probability of event E, subtract it from 1 and we get it the complement, and vice versa. If we already know the probability of event complement, subtract that from 1 and we get the probability of E. The one that's even more useful that's actually related to E complement is this one. If our outcomes are a collection of an amount of things happening, and we're like, hey, what's the chance that at least one of those things occurred? That's 1 minus the probability that nothing happened. So we're going to see this one demonstrated in our notes as well, or in our problems today.
Oh.
So that's the summary of the concepts you learned from the notes. Hopefully it sounds vaguely familiar. Of course, if you didn't watch the notes, then this seems all new and you're totally lost. And that's okay. You're going to go watch the notes and you'll now maybe taste them a little better. It's like you added salt to them. Or it's like an open wound. So here comes some problems and we're just going to pour some salt on that open wound. So we're going to start with Cindy's worksheet, page 552.
$5.52.
And based on what you got sent to you, I think, or is going to be sent to you, this is due Sunday, 10/9. Okay, so let's give you, why don't you try this? Let's do 5 minutes and let's just see if you can't answer the first page. Well, let's see if, let's do 5 minutes for just question 1. My phone's upstairs. I gotta go get that.
Can I ask a question or should I wait till you go over it?
Go away. I mean, go ahead. Yes, please go away. Yes, ask a question.
Jeez, Rick. Okay, so where it talks, okay, so like C, it wants to know about what outcomes make up the event green C. I think I'm having a little bit of an, is it? I guess I'm not understanding at the moment with the way, what the complement exactly is.
So it means everything that's not whatever this is.
Gotcha, okay. Okay.
All the outcomes in the sample spaces that are not outcomes. Ah. Well, then isn't C and D the same question? Technically?
No, because C says, what are the outcomes? And then D says, oh boy, what's the probability that those outcomes happen? So it's a subtle difference. The C is a list of words,
Gotcha.
and the D is that thing. Let me highlight a few things just to, is this, yes, it's still recording, yes.
Okay. So we have to list the outcomes, not the formula. It wouldn't be like 3/4. It would be blue, yellow, red.
Nailed it. That's exactly the answer.
Jesus.
Oh, yes, there is a recording from Wednesday. So, right, y'all, we did the first page of 5-1 on the 28th, 9/28 for the evening class. I think we also did it in the day class for that as well. I guess you could see if I said the same thing or not. Quick question. When we calculate these probabilities, when we do A, B, and D, are we calculating classical probabilities or empirical probabilities?
These are classical.
Why do you say
Empirical?
classical?
Okay, hang on. Let me.
You're correct, if that helps you feel better about it.
It's it is just common knowledge, common logic, known by logic. We know, I mean, it says, right?
It also says, Becky, that it's a equally likely outcomes.
Yeah, so we know all of the outcomes from the beginning. We have done nothing. We haven't done any spinning and recording of the spins and what happened. We're just like, hey, these are equally likely because they have the exact same amount of area. You flick the spin or you flick the spinner and it spins around and it's going to land one of them. And we know there's a 1 in 4 chance it will hit any of these because it's equally likely. That's theory. I don't know that that's logical, to be honest with you.
I don't, that's what I have in my notes.
But it's theoretical. Yeah, you're on the right track. Okay, so letter A, what'd you all get? What's the probability it's landing on red? Oh, wait, let me highlight one thing. Notice in this problem, we're doing this spin just once. When you do 5-3, we might hit the spinner 5 times and see what's the probability we got green 5 times in a row. So for now, it's just once. What'd you all say for red or blue?
Isn't it 50%, 240?
Nailed it.
Oh, I said 25%.
But the or means to add the two
That's
outcomes
right.
together.
So like if you were saying, if we were thinking about betting on this, if it lands on red, you win. If it lands on blue, you win. So what's the chances you win? Well, it's 2 out of 4 or 50% or 1/2, however you want to think about that.
Mhm.
Good.
So,
So what we're doing here is we're applying this formula right here. Oops. We're saying if we're asking between 2 events, add them together, provided they're disjoint. So maybe we need to go back and ask ourselves, are these outcomes disjoint?
I don't know.
So here's how you tell. Can the spinner land on red and blue at the same time?
No.
No.
No. So they're disjoint. Yeah, it can only be one of these four colors anytime you spin it. So that means it's appropriate what we did to just add the probability of each individual item together to get the chance that either or happens. And it turns out it's the same idea for red, green, or blue. You can string together as many ors as you want. And as long as they're disjoint, you just add the stuff together. So that's 1/4 plus 1/4 plus 1/4. That's a 3/4 chance of it happening. We already talked about this green complement. So it's all the things up here that don't say green. So yellow, blue, red. I put those squiggly brackets in there because that's how you list a set of items. That's in the math world that says, here comes a set of items. We talked about this morning. Some people said, is it okay if I do parentheses? And this has some very specific meaning in math. And for our class, it will mean an interval. The example I showed this morning was, if I wrote this, I would be talking about any number between 0 and 1, not including 0 and 1. So like 0.25 is technically in here, whereas this one, it's only those three items that we're considering.
So it has to be in those brackets? It
To be
can't just-
100% correct, yes, I'm not going to mark you. I don't tend to be too picky with this notation. I think it's important to start thinking about it because when we get to interval notation, you will have to write with parentheses. I
So,
might be picky on that one.
so like on question A, like if we were answering this on an exam, we would need to show the equation with the parentheses and then the,
Great question, Nicole. I didn't even think about that. No, all you need to write up here is the 1/2.
okay,
It's helpful for me to see what's happening. And here, these parentheses are even different than this one. They're just notational parentheses that say anything inside of this set of parentheses is what we're defining as the event. It's because we have that P in front. If we took the P off, then it would be, we wouldn't even know what we were talking about. We already answered this one too, right? This one was 3/4. But there's 1, 2, 3 outcomes out of 4 total. Another way to do this. Let's see if I can pull this off. It's not particularly useful here, but it's the probability of green complement is 1 minus the probability of it being green. So this is 1 minus 1/4. And then, you definitely want to do this in decimal, so you don't want to do it any other way. There you go, 3/4. I'm just kidding. I've been told you all like this one, that 1 is equal to 4/4. That's kind of overkill for this problem because there's only 4 outcomes. And if you're like, hey, what's the complement of one of them happening? You're like, well, it's the other 3. Why would I need to do any of this writing? And I totally agree with you. That's trying to put a picture framing nail on the wall with a sledgehammer. Questions on this? What'd y'all say for number 2? Love it, Hope. Yep. 0. If it's certain to happen, that means there's 100% chance. So we're saying that P of E is equal to 1. So what's the probability that its complement happens? It's got to be 0. How do we know? It's equal to 1 minus the probability E happened, which we know is 1. It has to be 0. Yep. Did y'all get to number 3?
That's one I was kind of stuck on for a second.
Easy to get stuck on. Anyone know another name we've used for probability?
Frequency.
You got it. relative frequency.
Relative
and that.
frequency.
So if that helps you calculate away,
Yeah.
maybe I'll just put this up here and see if it means anything to y'all. Once I think
No,
I,
that's
I
just-
think you know how to
You want us around
calculate.
3
it.
decimals or 2?
It says 3.
Oh, you did already. Okay.
No worries. So here I
What?
got this safe. Go ahead.
Mm.
So these numbers in B goes in under the probability. Right?
No, you got to calculate. Oh, you're talking. Yes. I'm sorry. Yep. So what I did here is first I added up what the frequency was. So I
Okay.
calculated this. That's 29.
Uh,
And then in Excel, I just wrote down the frequencies and divided each by 29 to quickly calculate the percentages. You might want to confirm that.
Okay,
So-
where?
Go ahead.
Okay, so you got the 29 from the frequency.
Yep, I did 8 plus 10 plus 4 plus 5 plus
Okay.
2.
Okay, and then how do I get the probability now? What's the, what?
Do you
what
remember
do I do?
relative frequency from chapters 2 and 3?
Yes, I take 8 divided by 29.
Nailed it. That's it. Good. So I did
Okay.
that for you quickly, since it can be tedious to do, 5 calculations? But yeah, as long as you remember that, you're good. That's how we got those probabilities.
Now, okay, so, and then, okay. So we're rounding 3 decimal places,
Why?
huh?
Why?
Because it says give 3 decimals.
That's the only reason. Yeah, good.
Okay.
Now they have that. Let me give you 2 minutes. How about I stay quiet for 2 minutes while you answer B through D?
So I got that.
All right, that was 2 minutes. So 1 or 4, what do you all say?
I said 1, but I'm probably wrong.
I got 5 over 29.
I have
Right.
29.
Well, what's the probability that we sell, that they sold 1 car in that week?
0.345.
Okay, good.
So we add the probabilities for 1 and 4
Okay, good. Why are we allowed to do that?
because it says or,
Okay, good.
and which
Do you
means
think
to
it's,
add.
do you think they're disjoint? So to answer that question, ask yourself, is it possible to sell 1 car and 4 cars at the same time in 1 week?
Yes.
Ooh, how would you do that? Because if you sold me 1 car and then you sold someone else 4 cars, wouldn't you have sold 5 cars?
Oh, are you asking? Well, I thought you meant like one of those would be 1 out of the 4.
Well, good, good. I'm glad you said that, Becky. So what you have to think about is these numbers are not used in the probability calculation. Those are the types of outcomes. You could think of 0 as yellow and 1 as green and 2 as purple or whatever if you want. So these have really nothing to do with the calculation other than they're telling us that the probability of a 1 is 10 out of 29 or 0.345.
Right.
And the probability of 4 is 2 out of 29 or 0.069. Since in the context here, this is a car person looking at their sales per week.
Mhm.
You can't have a week of sales where you sold only 1 car and you sold only 4 cars in the same week. That doesn't make any sense.
Yeah.
So the number of cars sold as outcomes are disjoint because they can't overlap.
Right. Okay.
Which is what allows us to do this. And then what is the sum of those two? I don't know.
0.414.
0.414. Let me just erase some of this.
That's what I got.
Nailed it. Oh, that feels good, Jen. 0.414. Okay. Ooh, look at this special word. Not. Did not
Don't
sell
you
3 cars.
So you would
But
subtract,
you subtract it.
Subtract what from what?
0.172 from 1.
Nice. Yeah, that's the shortcut. And in this
Okay.
case, I think it makes sense to do that because instead of adding up the probability of selling 4 and 2 and 1 and 0, we can save ourselves some time and just run this calculation and it gets us there faster. Do you have to? No. Add up the other 4 if that's easier for you. If that makes more sense, that's fine. There's no shame in that.
So we put in 1 first. And take that from 172.
Yes, well,
0.172, I should say.
whoops. Yes, because the order you subtract things is super important. The order you add things doesn't matter at all.
Okay. So
If you flip that order and you did 0.172 minus 1, you'd be claiming that there's a negative 100% probability of something happening.
oh, okay. Okay. So it's 1 minus 0.172.
Now check out this last one.
0.80.
We're saying, what's the chance of at least 1 car being sold? If you think through what that means 1 car or 2 cars. Oh, this is so annoying sometimes.
Oh.
Oh my goodness.
Isn't that the 0.345?
Well, it's that and above. It's all of these. So at least 1 means they sold 1 or 2 or 3 or 4.
Oh, so it's add them all up.
Or 1
Or
So what you subtract.
0.276.
yeah. So
Wait,
this is where
what?
that formula, the probability of at least 1 is the same thing as 1 minus the probability of none, because at least one, its complement is 0. So that's 1 minus 0.276. Again, if you'd rather add up the 4, that's fine, no worries.
Okay, now
Um,
I'm lost.
Well, so look at these outcomes. At least means how many, what does 4 match selling at least 1? Would that fall under that definition?
Say that again?
Does selling 4 cars fall under the phrase at least 1? Is 4 at least 1?
Yes,
Is 3 at least 1?
yes,
How about 2?
yes,
How about 1?
yes.
Oh, we just listed all of these outcomes. Is 0 at least 1?
No,
Ah, that's the complement, right? So this is the event of at least 1 is these 4 things. 0 is the complement of at least 1. So we can use the same thing we did in C, 1 minus the complement, which in this case is the 0.276. And maybe we get that calculation a little faster. This, by the way, is one of those ones that you kind of have to know in chapter 5 or section 5.3, because some of the calculations there are so insanely complicated that you couldn't do it. There's like 1,000 things you have to add up or calculate and then add up. So
okay, so for this answer, all I have to do is 1 minus 0.276 and I'll have the answer.
do you get why? That's more important than the answer.
No, if you want me to be honest.
Yeah, no, I do want you to be honest. Yes. Because if you look at the options for the outcomes, these 4 things represent at least 1.
Okay,
Is there anything left over in our probability model? Is there any option left over that we could still calculate?
no,
Well, what about this one?
it's not 1.
Yeah, so that's the complement of these other things. Remember the event and its complement together make up the whole model. They make
Okay.
up the sample space. So
Okay.
100% of the items minus this one item gets us these other 4. That's where this is coming from.
Okay,
Cool. Okay. We got to press forward a little bit because I want to give us some time to also do the next worksheet, which is the 5.2 one. It's okay if we don't get it all the way done. We can start tomorrow night on it. Let's do this one together real quick. The number 4. Here, we're just applying the definition of disjoint, which is also known as mutually exclusive. So remind us, everyone, or someone, what does it mean to be disjoint? What's that definition?
No overlap.
No overlap. Good. No common outcomes. The 2 things can't be true at the same time. Okay, so we're randomly, this doesn't tell us what the experiment is, by the way. I think we're at a school and we're randomly selecting students from the list of all students at the school. So option 1 is that student is female. Option 2 is that student is a junior. Can that happen at the same time?
Yes.
Right? There are female juniors. So that means it's not disjoint. If we had said randomly selecting a freshman and randomly selecting a junior, that would be disjoint because you can't be defined as a freshman and a junior. Although there's scenarios where that's kind of true, you know, like the kid that failed everything and they're aged junior, but they're credits wise a freshman. But we don't actually define grade by your age. Okay, how about this one? We're gonna roll a die. Now we actually know the experiment. Now the question is, how many sides do we think this die has? And I'm just gonna tell you that you should always assume a 6-sided die. So the sample space on this event, the number is odd, would be 1, 3, and 5. And then a number less than 4, the sample space on this one would be 1, 2, 3, 4. Okay, are these two events disjoint?
Mm,
Well, yeah, if you're gonna
no,
include
because there's
4,
overlap. There's an overlap.
What's the overlap?
3.
3,
Is there another one?
And 1.
1.
Yes. sorry.
Because those two outcomes are in both sample spaces or in both list of outcomes, that makes them not disjoint. If this had said a number greater than 4, still not disjoint, because 5 is also greater than 4. So that's what you're looking for. Is there something the same between the two events? If there are, then they're not disjoint. And that's where being able to list out all of the outcomes for the event is helpful, I think. You just look at them. Okay, let's see. How about we do 5 minutes for the two of these, and I'm going to stick to those 5 minutes. Let you try these, and then we'll go from there. Set a timer for 5 minutes. Alexa, where did I lose you? Or did we already answer that? Oh, I just saw your thing in the chat that said, sorry, you lost me, my computer died. Oh, you were just saying that you disappeared, or were you saying you needed help on something. Okay. Let's see how we're doing here. First note, we're given the size of the sample space right in the prompt. That was kind of them, right? 9 coffee shops, 3 at Starbucks, 2 Caribou Coffee, and 4 Crazy Moco or whatever that is coffees. I'm going to assume these are disjoint coffee types. We talked about that this morning, coffee shops, that you can't be a Starbucks and a Caribou Coffee at the same time. And so we're randomly selecting that we go to one of these. So what did you say to either or? Really, it's just the or, Starbucks or Caribou Coffee. What'd you all think?
I got 13 out of 27. Or 13 over 27. No, I'm reading the
Yeah.
wrong. I'm sorry. That was down. I got 7 over 9. Sorry.
Okay. That sounds a little better. So if you think about the probability that we picked a Starbucks shop, 3 out of 9.
Yeah.
Probability we got a Caribou Coffee, 2 out of 9. Excellent.
So it's
Come
5
on.
out of 9.
5 out of 9.
No worries. 5 out of 9. Now, no worries. I'm making the assumption that you all know how to do fraction arithmetic. And that is, if the denominator is the same number, you just add the numerators. So 3 plus 2 is 5, 5 out of 9.
Right.
How about not Starbucks? Another way of writing that is Starbucks complement.
So 6 over 9 or 2/3.
Nailed it. So
Are we
go
turning
ahead.
that to a decimal and a or a decimal and a percentage? Or just
You know, it doesn't even say. So whatever you want.
okay.
Becky, how'd you get 6 over 9?
I added Caribou and Crazy, which is 2 plus 4.
There you go. Yep. So
Oh,
two
yeah.
ways we could
Yeah.
Nice. Two ways you could calculate it. The other way to do it is 1 minus the probability that it's Starbucks. And I was told that you all like turning 1 into 9 out of 9 and subtracting from that 3 out of 9. And that gets you 6 out. What's wrong with my computer? That gets you 6 out of 9. But I like Becky's way too. In this context, like, you can just read it right there. There's only 3 things we have to work with. If there was 1,000 things, this complement mess would be super helpful, I think. In this case, not that helpful. And yes, Becky's right. 6 divided by 2, wrong again. 6
Wouldn't it
divided
be
by 3 is,
2/3?
yeah, is 2, yes. And I don't care about that. Like, that's what robots are for. I would accept either of these answers. Okay, awesome. Now, this one is tricky. I got this wrong this morning a bunch of times because I was real lazy with my reading. So we're looking at a poker deck that has 50, my internet's unstable. How is that possible? 52 cards in it, but we're modifying this deck by adding 2 jokers. And the parts I didn't read is it says here that one of the jokers is red and one of them is black. And these are face cards. So that takes our total of 54 or 52 up to 54, which means anytime any divisor, any denominator for any of these things has to have a bottom of 54. That's the size of the sample space. Now, if you don't know cards, I think we mentioned this on page 265. Here's the standard deck with no jokers. That's 52 cards, 13 of each suit, which means there's 26 red, 26 black. Face cards are these. There's 12 face cards, all that mess. So if you're not a card playing person and know nothing about cards, here's the information you need.
And that page is 265.
265, yep. And that's something you get to bring with you to the exam. Although when I take the options, I usually try to take off the gambling problems if I can. Although some people, it's a mixed bag on that one. There's some people that really like the gambling problems. Okay, so how many spades are there? Well, there's 13. How many hearts are there? There's 13. Is there a spade heart?
Yes.
What?
What?
A spade heart? No.
Sweetheart, no.
Ah, you're good. Yeah. Why did I ask that? What question? What's the reason for me asking that question?
To see if they overlap.
Are they disjoint? The answer is they're disjoint. So we just take the 13 out of 54 and add to it the 13 out of 54, and we get the nice fractional answer of 26 out of 54.
Yeah.
Do you want to simplify that?
13 over
Reduce
20.
it? Sure. Let's go to Desmos. We'll let Desmos do it, huh? 26 divided by 54 is 13/27. If that gets you excited, go for it. Tell me 13/27.
That does nothing for me, so I'm good.
Okay, if that does nothing for you, don't do it. I'm happy you figured out 26 out of 54. That's the important part. Cool. All right. Next question. Are there red aces?
Yes.
Okay, so these have overlap.
Yes.
All right, so how many red cards are there?
27.
Close.
20.
Oh, no, you're right. You're right. 27, that's the mess up I made. The reason it's 27 is because of the joker we added. Good. How many aces are there?
4.
Now, how many red aces are there?
2.
2.
Okay, so we counted 2 of those aces here, and we counted those 2 aces again here. So I have to subtract that overlap. So that's 29/54, and that's as simple as that fraction will go.
Awesome.
Okay, you just lost me.
Because,
Do you understand the red cards? Why there's a 27 over 54?
okay, yeah, let me write that down. Red cards. Yeah, it's the two, there's 13 of each, the hearts and the diamonds, plus the one extra for the joker, that gives us the 27.
Good.
There's
About
four,
the aces.
there's 4 aces.
And then this number, this fraction here is ace and red at the same time.
That's the overlap.
That's the overlap. And what you're seeing happen, this is the first not disjoint calculation we've had to do. And so what you're seeing, oh no, not that. That's quantitative reasoning. Is you're seeing an application of this full equation where we have to subtract that overlap. So that ace and red is this piece that we're subtracting from the sum of the two. How many face cards are there?
12. Plus
Close.
the figures,
14.
14.
12.
Is the
It's so
Joker
annoying that
Oh.
we did this little face guy over here, right?
There's, okay, so
So
showing faces?
I did, so I said the answer was, the card is not a face. So I said 40. Is that right?
Love it.
That's what I got too.
You did 1 minus 15 over, well, that's how many. The probability would be 40 over 54. Yeah. So you did this 54 over 54 minus 14 over 54 equals
What?
40 over 54.
It was just 20 over 27.
Which
I am,
super cared would be 20. Jen, what is the 1 represent?
the one is, I don't know.
All the cards, 100%, right?
Okay,
And then we're saying, hey, it's not a face card. Well, what I'm using here is that complement rule we used before, and that is if we know the probability, or it's 1 minus the probability of the complement. In other words, I'm doing the exact same thing here I did here and here. It's just a little trickier, right? Because we have all these dumb face cards with the 2 extra jokers that no one ever plays with.
so,
So the 1 is all of the cards. We're subtracting 14 of them that are face cards, and that leaves us with how many not face cards there are. Now, I just did this little trick that says, hey, do you remember what 54 divided by 54 is?
what,
you
54
remember-
divided by 54 is 1.
Okay, so I didn't do anything, right?
No,
I just put some clothes on this 1. Well, those clothes happen to make it the same type of number as this 14 over 54 so that I could subtract the tops. That's all I did. If you don't like that, by all means, check out Desmond.
yeah, I'm
1
still
minus
confused.
14 divided by 54. There you go. So just
So-
type in that thing and don't worry about the arithmetic.
14 over 54. Okay, so the answer is 20 over 27, or the,
Or 40 over 54, either one. Doesn't matter which. They're both correct. There are 40 cards in this deck that don't have faces on them out of the 54 total cards. In terms of a probability, we can simplify that to 20 over 27. I don't think this 20 over 27 is particularly useful, to be honest with you. If I wanted to better understand the chances of that happening, I would convert that to a decimal and say, oh, there's a 74% chance I randomly draw a non-face card.
okay.
Cool. Okay. So we got 24 minutes. It's not going to be enough time to get through the next thing, but that's okay. We're going to start it. We'll do the same thing. We'll do number 1 together, and then I'm going to skip number 2 because it's the simpler one, and we're going to do number 3. So we're doing the same thing we did in the word problem on the previous page. We're just determining if these events are disjoint. So our experiment is selecting a registered voter. Is it possible that we could have a mother who is also a Democrat?
Yes.
Yes.
No, all mothers are Republicans or independents, right? No, that's not true. Yeah, all right, so good, yes, it's not disjoint. That's possible, even if it wasn't true. Okay, then some voter is gonna ride to election day. We're gonna select a person who went to election day on 2020. I had someone write on their paper very angrily about, what is this crap doing on these worksheets? I was like, I don't know. So is it possible that they could, this voter, drive to the polling station or ride their bike to the polling station?
Yes.
Yeah, is it possible they could do both things at the same time?
I don't think you
No.
can
No.
ride a bike and drive a car at the same time.
But you could have a bike attached to or you could have a bike attached to a car.
There we go.
Yeah,
Or
But
on the
then
bus.
someone's driving you and you're just being
But it says
attached to the car.
bicycles, right? So
Yes. I
so
think if
it's,
we, go ahead.
so would that be a disjoint?
Yeah, I think if we don't think too hardly about it to come up with a way that you could bike and drive at the same time, you're good. Because there are those bicycles that have engines on them, right? But I guess we'd call that a motorcycle, sort of. This is intended to be disjoint. Maybe a clearer option would be the person walks or they drive. So yes, that's intended to be disjoint. Okay, we're going to skip number two, because number two is essentially the exact same question you did here in number one. We just made a few more options. We made the sample space a little bigger. So I'll let you try that one. If you get stuck on it, we'll talk about it in class on Wednesday. What I want to do is get to number three. And I will let's quickly fill in all this mess for the totals, because we need all the totals to answer the questions. And I don't particularly care about the totals. I assume everyone can type numbers in a calculator. Is that an okay assumption? I guess the one key thing is I'm adding across to fill the rows. So I'm adding these two numbers. And maybe I shouldn't make the assumption that this is a straightforward calculation. Does anyone need an explanation of how I'm getting these numbers?
This is where I actually got to join class from this morning, so I have them like they had them.
Oh, you want to tell them to me? That would be
I
awesome.
sure can. Okay, so the next one is 26, 67, 3. And then for males, it's 60 and then 518.
Thank you.
And females is 61455.
Okay, can everyone read the terrible handwriting? This one is probably the worst one right here. Oops. This
Yeah.
is 1909. Okay, so that's a matter of calculator work. Yeah, just adding across for the rows, adding down for the columns. Okay, now you need to be, let's make a few notes about this. What is this? Well, we asked 121,973 people who were within these ages, what's your health insurance status? Meaning, what type of health coverage do you have? Doesn't say the year. Who knows? And then we classified by gender and by type. Now, based on our classifications, you should assume in this scenario that gender is disjoint. Okay, so you can't have someone stating that they're male and also stating that they're female. I'm assuming the poll allowed you to only pick one. The other other assumption you should make that may not actually be true is that the type of insurance someone has, we're assuming is disjoint as well. Now, it's certainly possible that you could have a combination of insurances like private and Medicaid and whatever. But for this problem, assume that each of these rows is a disjoint outcome. Now, I told this morning's group, this type of table, reading this table is particularly important for the nursing students going into nursing, because these are very common tables that you're going to be seeing in research articles and stuff in the medical field. We're going to talk later about sensitivity and specificity, which is also related to what these are called two-way tables or contingency tables. So another key point, we're selecting a person. One person is being selected. When you get through the notes tomorrow, we're going to repeat this type of problem and we're going to select 3 people or 5 people, and it changes the probability and it becomes, it's a little trickier. So that's coming. All right, so let me give you 5 minutes to attempt this and see if you can't get someplace. One of the things for this problem to note is whenever you're writing in your fractions, the bottom of the fraction should be this. That's the total. All right, try it out.
I'm already stuck. For B,
Mm-hmm.
would I divide the total men, the 6518 divided by 121,973?
Definitely. Here's why. Anytime you calculate a probability, you're taking the total outcomes of the event. You got it, that male 60 whatever, by this total outcomes in the sample space. Yep. Nailed it. Wait, I'm supposed to say, why do you know that's correct? I got to work on that. I went to a conference this weekend about how to be a better math teacher. Good. I'll write that one down for everyone's. For right now, you're supposed to give 4 decimal places, but that's just calculator work. Like I'm not as excited about that. Getting what you need to type in your calculator to me is the most important. We can come back and fill all this in later if you want.
Right the first time.
Oh yeah. See, yeah.
Oh, you forgot a number. Okay, I thought I had it right. Yep. So give 4 decimal places.
Oops, I sorry, I thought I was muted.
Point.
Jen, for now, don't worry about the decimal places because that's just smashing it in a calculator. For now, see, make sure you can set up all of the fractions.
Okay.
To me, that's the far more important part.
So do I put a P in front of that fraction or?
Oh, if you're wanting to write the symbolic notation, that would be the probability of selecting a male. That would look like this is equal to that fraction.
Okay. So,
So I thought I was muted. Sorry, I knew that was going to happen at least once.
so.
That was 5 minutes. Do we need a few more minutes?
Are we trying to get through the whole page?
Yeah. Can you get the whole page?
I'm not done yet, but you can.
Ryan,
Oh, let me give you some more time. We can do 5 more minutes. Set a timer for 5 minutes.
Mm-mm.
Okay, that was 5 more minutes, and we are 6 minutes out. So let's talk through so that you can check your answers. Let's talk through what we got. Okay, uninsured is its own row. So it's a fairly straightforward calculation in that we got to decide how many people are uninsured. We calculated that already. That's the 26,673 divided by 121,973. How do we feel about that?
Good.
Good.
Good. Now, not uninsured is these other three, which is the complement of C. So we could just do 1 minus whatever C is. And here I'm going to bother to do the decimals because, oh, fail.
I'm
2187. I'm bothering to do that now because since we already know the uninsured, not uninsured is just 1 minus uninsured, which is a faster calculation than trying to add up all of these things, in my opinion. The 1,000 plus the 9,000 plus the 83,000. Is that okay?
Yeah.
Okay, then we're asked, what about private insurance or Medicaid? Well, we have to first observe that private insurance and Medicaid are disjoint outcomes. Based on this table, you can't have private insurance and Medicaid. So we just simply add together those two numbers. Now, we could add them together and then divide by 121, or we could write them separately. Mathematically speaking, that's the same thing. I'm going to write them separately just to help you see maybe where they each come from. So here's the probability of selecting someone with private insurance. Add to that, because they're disjoint, the 9,524 for Medicaid and 121,973. By the way, I think the reason Medicaid is so much lower, correct me if I'm wrong, is because of the age group. Isn't Medicaid for like over 55 or something like that?
Yeah, something like that.
Primarily.
Medicare is over 55 and watch it.
but also for children.
Okay.
I mean, because I'm 36 and I have Medicaid. So
I thought there was, I think there's different, yeah, there's like different, I don't know the circumstances, but there's different names for these, like Medicaid, Medicare, isn't there even a third one?
yes.
Okay. So you can see here, the context is not very kind to me because I don't know a lot of it. All right, so this is some number. We can come back and calculate it. Now, check out, go ahead.
Oh, on that one, E, you're doing it separate,
Mhm.
but I added the two together
Well,
and
guess what the
then
math says? Yeah,
divided.
that's totally fine because this is what mathematically is going to happen. You're going to add the two numbers together and then divide. So it's the same thing. Yeah, not a problem which way you do it.
Okay, I got a different.
You'll
Oh,
get the same answer in the
no.
end.
Okay, okay,
Yep, you'll get the same answer once you actually add those two together.
okay.
Now, look at this, and I'm going to come back and do them all real quick, write out the decimals, but I want to make sure we've had a chance to at least look at these special words for each one. There we go. Kayla's got it. 93,391.
What?
Nice hope.
But didn't they
This-
want the,
Oh, yeah, and then turn it into a decimal. Yeah. Okay,
Oh.
so look at this word and. What does that mean in this context?
That it's one specific gender with
Well,
the type of insurance.
yeah, both of those things have to be true. So it's not all of the males and all of the private insurances, it's the private insurance males that we're interested in.
So when,
Right.
It's the
41
overlap only.
right,
So the 41,209 divided by the 121,973. Okay.
That's it. That's it. You didn't have a question yet that asked you to calculate that directly. The closest we got is this one here where we did the aces and red. And we used it as part of the larger calculation. We're down here, you were just asked, what's the probability that these two things happened at once? That both of those statements are true. Then we get to the most complicated question here, and that is female or private insurance. So I'm going to do it the long way. And that is, let's see, how many females are there? 61,455.
Mhm.
That's what's wrong. My laptop is overheating. So let me get that down and we're out of time. Sorry, if you all need to take off, take off. So female total was 61,455. Plus, what is up with my internet? Plus, how many private insurances are there? Let's see, private is this row, 83,867. Oh, we used it right here. Now, are these two things disjoint?
Hi.
I'll show you why they're not.
it overlaps.
Yeah, nice. So here comes private. That's the row of that. And here comes female. That's the row of that. Oops, right? You see right there, we counted the number of females that have private insurance twice. This little area right here got shaded twice. So we can't do that. It's like an inflation of that probability. So we have to subtract that 42,865 from this total. And then we'll have the correct calculation. How do y'all feel about that? Other than I didn't get the right number.
I'm
658.
confused on that one. I'm trying to figure out.
Do you get this overlap? Do you get what I'm talking about? That this got counted twice? So if I draw this, I added 41,209 and 42,658, and I got the 83,000, right? And then if I added this column together, 42 plus 6,000 plus 1, blah, blah, and I get the 61,455, I added this 42 in there. That got added twice.
Okay.
Used in both of these numbers. So to keep from
So
calculating,
is that like the aces?
Go back down, please. Yeah. Okay, so
I'm going to fill in these decimals while
So-
we're thinking.
so that's why you add the total up, but then you take one of them back off, basically.
Why? You tell me why. Why did we do that?
Because we don't want the 42 on there twice.
Yeah, it's double counting those females. They got counted twice and there wasn't twice that many people in the survey, right? So we created a false reality. So we have to subtract that out. Yeah, to keep it from, to
Now,
keep it correct.
before we do the addition and subtraction, we do the division first, correct?
Yeah, you can add and subtract the tops and then divide by the 121.
Okay,
So how I'm gonna do it in this little junk calculator is I'm gonna do the 61,455 plus 83,867 minus 42,658. And that's just adding together all the top values. So there's 102,664 unique options up there. And then I'm gonna divide that by the 121,973. That's if you're using a junk calculator. You could type all three fractions in Desmos and it'll spit out this nice decimal, which I encourage you to do.
So Eric, I
Yeah.
missed the subtraction part of G. So when
Mhm.
we're looking at those kinds of questions, we really need to pay attention to how they land on the chart to pick that up, aren't we?
If
Because I
there's
totally missed
overlap, you get, yes, if they're disjoint. Yep,
Because when you did that,
Essentially,
I'm
what-
like, oh yeah, that makes sense, but I didn't catch it.
right. It's easy to
Right.
miss. It really
Okay.
is. Well, essentially what, in terms of a two-way or contingency table, it's always going to be if you're adding rows and columns, there's always going to be overlap.
Okay.
Okay, so that means we still have one more page to do on class on Wednesday, but you all try it. See if you can't do this. It's a tricky one because it's all letters and words, not a whole lot of numbers till the very end. So you all try that.
Can you scroll
And
up so I can check my last answer, please?
Yeah, which we're at here.
G, I was just checking my,
Let me box in all the decimals. So I went ahead and smashed everything in the calculator. If you're still working on decimal, rounding to a particular decimal, no sweat. That's not as important to me as being able to set up the fractions correctly. So those are those are all the answers. B, C, D, E, F, and G.
Is G right?
Did I get it wrong?
I don't know. Maybe I
Well-
did, but I got something different. Let me.
that's
make
what
sure.
I,
That's
It's
what I got.
right.
It's right.
okay.
Okay.
It's always good to question me. Make me double check. So on Wednesday, we just have 5.3 to work through, and I think, yeah, we'll still probably have 2 worksheets, but we'll have time. We spent a lot of time on chapter 4 and 5.1 today at the beginning, full half an hour. So we would have gotten this whole thing had we not done that.
Eric, I may have a chance to do my 5.3 worksheet along with the notes tomorrow. So then maybe you could take a look at, just start looking at maybe one of the, there's 2 review worksheets for this unit. There's a
Yeah.
review worksheet 1 and a review there's actually 4, but I think you had in your thing that you're only doing the first 2. The third and the fourth one were on roulette and dice, which
They
the
don't cover
gambling
enough.
stuff, which you didn't even have that in your
Good.
shell.
So we'll skip those for sure.
Yep.
Okay, y'all. Well, that's that. We'll do those in class on Wednesday, the reviews and the 5.3. And we'll be done with chapter 5. And then we only have chapter 6, and it is midterm time. Hooray.
Chapter 6 is only 2 sections, so. And it's a
remember-
lot of stat crunch.
Yes, it's all stat crunch. See you, Alexa. have a good night.
Night, Kayla.
Yes, yes, I encourage everyone, check out, if you haven't had a chance to see the notes, check those out, get those filled in to help you.
I had a
um,
question about that, Eric, on your,
Yeah.
today you've got 5.3 worksheet 3, but we did 5.2 worksheet 3. Is there a difference?
It's just the days are not exactly on. Just look for the worksheet. Don't look for the day.
Here, I'll
Okay.
move it down here. We're gonna do 5-3 on Wednesday.
Did you say you wrote out the sheet again, Cindy, or no?
Yeah, it's sent to you.
Okay, great.
So we did it, we've done
My
these two
lifesaver.
orders here. And we essentially did nothing on, yes, on what did we do on the 28th? Well, I guess we did, technically, we were supposed to have had 5-1 done from the 28th.
Yeah, everything's just moved on a day, Eric, because we pushed out chapter 4 a day because they needed another day.
That's right.
I
That's
have
right.
a question.
Yeah.
The forum, are we supposed to reply to,
You do not need to.
so we just put our response in and that's it?
Yep.
Okay. I will be in class on Wednesday, but I'll be driving back from Lansing. I have to go actually drive to the office for training. And it's like an hour and a half, hour and 45-minute drive. So I'll be on my phone, but I won't be able to take notes or anything, but I'll just watch the video after. But as soon as I get back home, I will jump on. I just wanted to give you a heads up.
Okay.
Sounds good. Sounds good.
Yeah, I'm going to be gone Thursday, so I will just check the video.
I know people hate this, but we might have to make a decision about maybe removing one of these because of where we're at in time. The sample midterm exam is the most important item to work on. So we might need to do one less of one of these worksheets for time's sake. Maybe not. Maybe we should just leave them all in. And we just won't have time in class to do all of them.
I don't mind doing them outside of class because it helps me be a little more independent with it.
Yes.
By all means, let's keep that going. Cool.
What time do you guys get done with work though, Nicole and Becky?
5.
Right now I get home I'm working a little bit different hours because of this class. My boss is so kind. So I'm usually home by between 4 and 4:15.
So I am too, and then I'm still running around like a chicken before
I'm-
6.
Usually eat dinner in class, which is,
So, yeah. Okay, just wondering. All right, I'm gonna go. See you guys.
See ya.
See you.
Night.
all right,
You guys tomorrow.
okay.
Bye.
Oh, we can stop recording this.